Hello and welcome to another episode in our AWS Certified CloudOps Engineer Associate Ultimate course. Friends, we are starting with question number 42 in this part of our series. A company has an Amazon EC2 instance that supports a production system. The EC2 instance is backed by an Amazon Elastic Block Store volume. The EBS volumes drive has filled to 100% capacity, which is causing the application on the EC2 instance to experience errors. Which solution will remediate these errors in the least amount of time? Your options are modify the EBS volume by adding additional drive space, log on to the EC2 instance, and use the file system specific commands to extend the file system. Create a snapshot of the existing EBS volume. When the snapshot is complete, create an EBS volume of a larger size from the snapshot in the same availability zone as the EC2 instance. Attach the new EBS volume to the EC2 instance and mount the file system. Now the third option is create a new EBS volume of a larger size in the same availability zone as the EC2 instance. Attach the EBS volume to the EC2 instance and copy the data from the existing EBS volume to the new EBS volume. And friends, the final option is stop the EC2 instance, change the EC2 instance to a larger instance size that includes additional drive space, and start the EC2 instance. Now, Amazon EBS supports elastic volumes, which means you can dynamically increase the size of an existing EBS volume without downtime. After increasing the size from the AWS Management Console or CLI or API, you simply resize the file system inside the OS. This approach avoids creating snapshots, attaching new volumes, or stopping the EC2 instance. So it is the fastest and least disruptive, which is the key requirement in this question. Next question, folks. A company has scientists who upload large data objects to an Amazon S3 bucket. The scientists upload the objects as multi-part uploads. The multi-part uploads often fail because of poor end-client connectivity. The company wants to optimize storage costs that are associated with the data. A CloudOps engineer must implement a solution that presents metrics for incomplete uploads. The solution also must automatically delete any incomplete uploads after 7 days. Which solution will meet these requirements? Your options are review the incomplete multi-part upload bytes metric in the S3 storage lens dashboard, create an S3 lifecycle policy to automatically delete any incomplete multi-part uploads after 7 days, implement S3 intelligent tiering to move data into lower cost storage classes after 7 days. Create an S3 storage lens policy to automatically delete any incomplete multi-part uploads after 7 days. The third option is access the S3 console. Review the metrics tab to check the storage that incomplete multi-part uploads are consuming. Create an AWS Lambda function to delete any incomplete multi-part uploads after 7 days. And finally, use the S3 Analytics storage class analysis tool to identify and measure incomplete multi-part uploads. Configure an S3 bucket policy to enforce restrictions on multi-part uploads to delete incomplete multi-part uploads after 7 days. Now, folks, Amazon S3 storage lens provides the incomplete multi-part upload bytes metric, which shows storage consumed by parts of failed uploads. This satisfies the requirement for visibility into incomplete uploads. So let's rule out option C and option D, which don't include S3 storage lens as part of the solution. Now, Amazon S3 lifecycle policies allow you to specify an action to abort incomplete multi-part uploads after a certain number of days. In this case, you configure it for 7 days, which automatically removes failed or abandoned parts and reduces costs. Now, folks, option B involves S3 intelligent tiering, which is for cost optimization of completed objects, not incomplete multi-part uploads. Also, S3 storage lens does not delete objects. It only provides metrics. Next question. An e-commerce company uses an Amazon ElastiCache for Redis cluster for in-memory caching of popular product queries on a shopping website. The cache eviction policy is randomly evicting keys whether or not a TTL is set. A CloudOps engineer must provide A CloudOps engineer must improve the cache hit ratio without increasing costs. Which solution will meet these requirements? Your options are add another node to the ElastiCache cluster, increase the ElastiCache TTL value, change the eviction policy to randomly evict keys that have a TTL set, change the eviction policy to evict the least frequently used keys. Now friends, the problem here is that the current eviction policy is random, which evicts keys regardless of popularity or TTL. This lowers the cache hit ratio because frequently accessed items can get evicted even though they are valuable. You should change the eviction policy to least frequently used eviction policy. Redis will keep frequently accessed key in memory and evict less used once when memory is full. This improves the cache hit ratio without adding cost. Folks, there is a link on your screen. Feel free to go through the link to understand more about the different type of eviction policies available while using Redis. Let's look at question number 45. A company's web application runs on Amazon EC2 instances in a single AWS region. The infrastructure must be designed so the application remains available with no performance degradation in the event of an availability zone failure. To ensure optimal performance, the application must maintain a minimum of 12 instances at all times. Which solution will meet the requirements with the fewest running instances possible? Your options are 2 AZs with 6 instances in each AZ, 2 AZs with 12 instances in each AZ, 3 AZs with 4 instances in each AZ, and 3 AZs with 6 instances in each AZ. Now folks, the key to answer here is fewest running instances. So let's analyze each option. Now option A involves 2 AZs with 6 instances each. After losing one AZ, we are left with 6 instances, which is less than the requirement of 12 instances, so an incorrect choice. Now option B has 12 instances in each AZ, so we are left with exact required number of instances, that is 12 after losing an availability zone, but we have a total of 24 instances. So let's see if there is another option which satisfies the requirement with less number of instances overall. Option C has 3 AZs with 4 instances each. So the number will go below 12 if we lose an availability zone, which means we can rule out this option straight away. Now option D ends up with an overall of 18 instances, and after losing an availability zone, we still have 12 instances, satisfying the requirement with less running instances than option B, making it a correct choice here. Folks, if you still have any doubts on why I went with option D as the correct choice, then please post them in the comment section. Next question. A company has a stateless application that is hosted on a fleet of 10 Amazon EC2 on-demand instances in an auto-scaling group. A minimum of 6 instances are needed to meet service requirements. Which action will maintain uptime for the application most cost effectively? Your options are use a spot fleet with an on-demand capacity of 6 instances, update the auto-scaling group with a minimum of 6 on-demand instances and a maximum of 10 on-demand instances. Update the auto-scaling group with a minimum of 1 on-demand instance and a maximum of 6 on-demand instances. Use a spot fleet with a target capacity of 6 instances. Now friends, application is stateless, so spot instances are safe to use because termination won't break state. So let's rule out option B and option C here, which just use on-demand instances, as we need to minimize cost as well. Now option D is a spot fleet with target capacity, which means all spot instances that can lead to an issue where service requirements are not met if all 6 of them go offline. So let's rule out that as well, making option A as the correct choice. Now folks, as always, there is a link on your screen. Go through it to understand more about spot fleet and how it can be configured. Let's look at question number 47 of the series. A company stores its internal data within an Amazon S3 bucket. All existing data within the S3 bucket is protected by using server-side encryption with Amazon S3 managed encryption keys. S3 versioning is enabled. A CloudOps engineer must replicate the internal data to Amazon S3 bucket in a different AWS account for disaster recovery. All the existing data is copied from the source S3 bucket to the destination S3 bucket. Which replication solution is most operationally efficient? Your options are schedule an AWS batch job with Amazon Event Bridge to copy new objects from the source bucket to the destination bucket, create a batch operations IAM role in the destination bucket. Now the second option is configure an Amazon S3 event notification for the source bucket to invoke an AWS Lambda function to copy new objects to the destination bucket. Ensure that the Lambda function has cross-account access permissions. Add a replication rule to the source bucket and specify the destination bucket. Create a bucket policy for the destination bucket to allow the owner of the source bucket to replicate objects. Run a scheduled script on an Amazon EC2 instance to copy new objects from the source bucket to the destination bucket. Assign cross-account access permissions to the EC2 instance role. Now friends, the correct answer here is option C. Using S3 cross-account replication with a replication rule on the source bucket and a bucket policy on the destination bucket is the most operationally efficient solution for replicating data between S3 buckets in different AWS accounts. Next question. A company is running an e-commerce application on AWS. The application maintains many open but idle connections to an Amazon Aurora DB cluster. During times of peak usage, the database produces the following error message: too many connections. The database clients are also experiencing errors. Which solution will resolve these errors? Your options are increase the read capacity units and the write capacity units on the database, configure RDS proxy, update the application with the RDS proxy endpoint, turn on enhanced networking for the DB instances, modify the DB cluster to use a burstable instance type. Now folks, you should configure an RDS proxy and update the application with the RDS proxy endpoint to resolve the issue in this case. This reduces number of direct connections to Aurora and handles many idle connections efficiently, improves scalability. Question number 49 of the series. A CloudOps engineer configured VPC flow logs by using the default format. The CloudOps engineer specified Amazon CloudWatch logs as the destination. This solution has worked successfully for several months. However, because of additional troubleshooting requirement, the CloudOps engineer needs to include the TCP flags field on the flow logs. What should the CloudOps engineer do to meet this requirement? Your options are create a new flow log, include the TCP flags field in the custom log format, and delete the original flow log. In the CloudWatch logs log group, modify the filter to include the TCP flags field and the type field. In the CloudWatch metrics, modify the metric configuration to include the TCP flags field. Modify the existing flow log, include the TCP flags field and the type field in the custom log format, save the configuration. Friends, you must recreate the flow log with the desired custom fields. You cannot modify an existing flow logs format and you must recreate it, which is why option D is incorrect. Question number 50 of the series. A company has implemented a Kubernetes cluster on Amazon Elastic Kubernetes service to host a microservices based application. The company expects application traffic to increase significantly for the next month and want to prevent the application from crashing because of the high number of requests. Which solution will meet these requirements with the least administrative overhead? Your options are: create a second EKS cluster, load balance the workload between the two clusters, implement the Kubernetes horizontal pod autoscaler, set a target CPU utilization percentage, migrate the application from Amazon EKS to Amazon EC2 for the next month, migrate the application back to Amazon EKS when the month ends. Implement the Kubernetes vertical pod autoscaler. Set a target CPU utilization percentage. Now friends, horizontal pod autoscaler automatically scales the number of pods in a deployment replica set based on CPU or memory utilization or custom metrics, making it the best choice to meet the given requirements. This approach also requires very low administrative overhead once configured. Option A and option C introduce high operational overhead, and option D is less effective for handling traffic spikes. Folks, I hope you now understand why I have chosen option B as the correct answer, but if you still have any doubts, please post them in the comments section. Question number 51 of the series. A CloudOps engineer has many Windows Amazon EC2 instances that need to share a file system between nodes. The CloudOps engineer creates an Amazon Elastic file system file share. After creation of the file share, the CloudOps engineer is having trouble mounting the file share to the EC2 instances. Which action should the CloudOps engineer take so that the EC2 instances can share the files? Your options are: use the correct IAM credentials to mount the EFS file share, configure NFS version 4 support on the Windows operating system that is running on the EC2 instances, allow the correct port for NFS through the security group and network ACL, delete the EFS file share, create an Amazon FSX for Windows file server file share for the EC2 instances. Now folks, FSX for Windows file server provides native assembly support for Windows EC2 instances, making file sharing seamless. Option A talks about IAM, which is not involved in mounting. EFS uses NFS network access, not IAM credentials. While Windows has optional NFS client features, AWS does not support EFS with Windows EC2 instances via NFS, making option B as the incorrect choice. Now option C is required for Linux EC2 instances mounting EFS, but Windows still won't be able to use EFS properly. Let's look at question number 52 of the series. A CloudOps engineer manages policies for many AWS member accounts in an AWS organization's structure. Administrators on other teams have access to the account's root user credentials of the member accounts. The CloudOps engineer must prevent all teams, including their administrators, from using Amazon DynamoDB. The solution must not affect the ability of the teams to access other AWS services. Which solution will meet these requirements? Your options are: in all member accounts, configure IAM policies that deny access to all DynamoDB resources for all users, including the root user. Create a service control policy in the management account to deny all DynamoDB actions. Apply the SCP to the root of the configuration. Create a service control policy in the management account to deny all DynamoDB actions. Apply the SCP to the root of the organization. In all member accounts, configure IAM policies that deny Amazon DynamoDB full access to all users, including the root user. Remove the default service control policy in the management account. Create a replacement SCP that includes a single statement that denies all DynamoDB actions. Now folks, you should make use of SCPs here, which means you can rule out option A and option C. SCPs affect all users and roles, including the root user across accounts where applied, and you should create a SCP that denies only DynamoDB actions while allowing access to all other services. Best practice would be to add a new SCP with an explicit deny for DynamoDB, not remove defaults, which is why I have ruled out option D here. So folks, that's all for this part of the series. If you are someone who has come across our videos for the first time, make sure to explore the previous parts of the playlist as well. Link to the playlist is available in the description section of the video. If you have not subscribed the channel yet, make sure to hit that subscribe button and turn on the notifications so you are notified on when the further parts in the series are released.